Okay, and I'm back. This is chapter 15, part 4. There's a lot to chapter 15, and I don't want my videos to run too long. So we're still going to calculate adjusted flow rates. And I call them percent of variation problems. / adjusting flow rate. So we got through example 15, so we're on example 16 now. And the order is lactated ringers, 1,500 milliliters or 1,500 milliliters, IV for 12 hours at 125 milliliters per hour. And our drop factor is 20 drops per milliliter. And we know that after 6 hours, there are 850 milliliters remaining. Describe your action. Okay, so this is just like the other. The hospital gives a 25% variation, or allows a 25% variation with careful patient assessment. All right, 16, I have it set up a little bit different because it doesn't give me an original flow rate in drops per minute. It did give me a drop factor, so I know mine has to be in drops per minute. So I have to find the original flow rate. So I can do it the shortcut way, or I can do it the long way. If we were in class, I would ask you which way to do it. I'm going to do it the long way. So I've got 125 milliliters per hour. That's my total volume over my total time, times my drop factor, 20 drops per milliliter, times my time conversion, 1 hour over 60 minutes. So I know 20 goes into 120 times, 20 goes into 60 3 times. My hours cancel, my milliliters cancel. So I've got 125 over 3, and it'll be in drops per minute. So 125 divided by 3. That gives me 41.7. So I got to round it. I'd round it to 42 drops per minute. But again, I'm okay if you do 41 drops per minute. All right. So let's use the 42 drops per minute as our original. And then the next thing I have to find is the time remaining. Okay, I know this was supposed to flow for 12 hours. After 6 hours is when I checked her. At the 6th hour, I checked it. So 12 hours minus 6 hours means that I have 6 hours remaining. And then I have to determine my adjusted flow rate. Or I could call it my new flow rate. So I take my amount remaining, which is the 850 milliliters, over my total time remaining, which is 6 hours, times my drop factor, because I'm still using the same tubing, so the 20 drops per minute, and then times my time conversion. It's not per minute, that's per milliliter. Hour and 60 minutes. So again, 20 goes into 20 once, 20 will go into 63 times. So I have 850, so I didn't cancel out my milliliters or my hours, over 6 times 3, which is 850. 6 times 3 is 18. So 850 divided by 18 is 47.2. So I would round that to 47 drops per minute. It doesn't round up, so it only stays the same. All right, so that's my adjusted. And then I want to find my percent of variation. And the formula I probably should have gave you earlier, I'll do it this way this time, is the new, or maybe I should say adjusted flow rate, minus the original, divided by the original, times 100. That way we end up with a percent. So I have my new, which is 47, minus my original, which is 42, divide by 42. 47 minus 42 is 5, divide by 42, times 100. Equals 11.9%. We could call that 12%, but it's still less than the 25% allowed. So what am I going to do? I'm going to adjust the flow rate to 47 drops per minute. So that's my final answer. If we were in class, I'd have you do this next one by yourself, but we're not in class. But if you want to pause here and work number 17 on your own and then come back to the video, you can, and see if you're working just like I did. So number 17, my order is for normal saline, 2,000 milliliters, IV for 12 hours at 167 milliliters per hour. We have a drop factor of 10 drops per milliliter. And then it says after 8 hours, there's 750 milliliters remaining. And then it says describe your action below. Alright, so I've got it set up the same way again. This time I want my original. And it gave me a rate. So I did the other one the long way. I'll do this one using the shortcut. I want drops per minute. So I'm going to take my 167 milliliters per hour. I've got 10 drops per milliliter, which has a constant, has a drop factor constant of 6. So I'm going to divide that by 6. That goes away. So 167 divided by 6 is 27.8 drops per minute. So I'm going to use, well, I can't say drops per minute because I got to have a whole number. 28 drops per minute. Or you could say 27 drops per minute. The amount of variation won't be much different. So I'm going to have set it at 28 drops per minute. And then I have to find my time remaining. Because it's not always going to be half. So we started with 12 hours. And then we said after 8. So I'm going to subtract 8 hours because that's what's already went through. So 12 minus 8 gives me 4 hours. So I have 4 hours remaining, as well as 750 milliliters remaining. So now to do the adjusted flow rate, I'm going to take my amount remaining over my time remaining times my drop factor times my times conversion, hours to 60 minutes. So my amount remaining is the 750 milliliters. My time remaining is the 4 hours. My drop factor is the 10 drops per milliliter from way up here times 1 hour over 60 minutes. So my 10 goes into 60 one time. My hours cancel, my milliliters cancel. So now I have 750 divided by 4. Equals 187. Something's not right. $750 milliliters remaining. I have 4 hours remaining. 10 drops per milliliter. So 750 divided by 4 is 187.5 drops per minute. Alright, so found out my problem. 10 goes into 66 times. So 750 milliliters over 4 times 6, which does not give me that. So I'm going to have 750 over 6 times 24. So 750 divided by 24 gives me 31.25, which would give me 31 drops per minute. Okay, so this is my adjusted. So now I have to do the percent of variation. So it's the new minus the original over the original times 100. So my original, or my new, is 31. The original is 28. And I'm going to divide it by 28. 31 minus 28 is 3 over 28. So 3 divided by 28. And then it's got to be times 100. Which gives me 10.7%, which would be 11%, which falls within our variation, or falls within our allowable 25% of variation. So I'm going to adjust the flow rate to 31 drops per minute. Okay. I'm going to let you do 18. And I'm going to end the video here. The answer key is on Canvas, so you'll be able to find it. I'll come back with part 5.